Electron microscope, a window into the infinitesimal. The electron microscope, a groundbreaking technological marvel, has revolutionized our understanding of the world around us. By harnessing the power of electrons, this instrument provides scientists with an unprecedented view of the microscopic realm, revealing the intricate details of atoms, molecules, and countless other tiny structures. How does it work? Unlike traditional light microscopes that use visible light to illuminate objects, electron microscopes employ a beam of electrons. These electrons are accelerated to high speeds and focused onto the sample being examined. As the electrons interact with the sample, they produce signals that can be detected and converted into an image. There are two main types of electron microscopes, the transmission electron microscope TEM and the scanning electron microscope SEM. TEMs work by passing electrons through a thin slice of the sample, allowing scientists to observe the internal structure of cells and materials. SEMs, on the other hand, scan the surface of a sample with a focused electron beam, providing a detailed view of the external topography. A brief history. The development of the electron microscope was a significant milestone in scientific history. The first TEM was invented in the early 1930s by German physicists Ernst Ruska and Max Knoll. Their groundbreaking work laid the foundation for the development of modern electron microscopes, which have become indispensable tools in fields ranging from biology and materials science to nanotechnology and medicine. Particle physics and the electron microscope. The electron microscope has played a crucial role in advancing our understanding of particle physics. By enabling scientists to visualize and study the structure of atoms and molecules, this technology has provided valuable insights into the fundamental building blocks of matter. For example, electron microscopy has been used to investigate the properties of quarks, the elementary particles that make up protons and neutrons. The nature of matter, energy and vibrational energy. Matter, the substance that makes up everything in the universe, is composed of atoms and molecules. These tiny particles are constantly in motion, possessing kinetic energy. Additionally, atoms and molecules can vibrate, storing potential energy in the form of vibrational energy. According to Einstein's famous equation, E equals mc squared, energy and mass are interchangeable. This means that matter can be converted into energy, and vice versa, a concept that has profound implications for our understanding of the universe. Conclusion. The electron microscope is a remarkable instrument that has opened up new frontiers of scientific exploration. By providing us with a glimpse into the microscopic world, this technology has helped us to unravel the mysteries of nature and advance our knowledge in countless fields. As we continue to develop and refine electron microscopy techniques, we can expect to make even more groundbreaking discoveries in the years to come. Thank you for watching. Please subscribe, share, and like this video. This article was produced with the help of AI and some very smart smartphones. God bless to you and yours.